This should be a pretty quick, simple video here. We're going to talk about proving lines parallel. When we talked about our corresponding alternate interior, alternate exterior, same side interior, same side exterior angles with parallel lines and a transversal, we were given the conditional statement, if then conditional statement, somewhat like if two lines are parallel, then corresponding angles are congruent. We are now going to do the converse. We're going to say these corresponding angles are congruent, therefore the lines are parallel. So we're going to switch those around. So guys, all it is figure out what kind of angles you have and throw the word converse. That's the theorem or postulate that we're going to have. So again, your corresponding angles converse is saying that you've got two corresponding angles and they're congruent, so the lines are parallel. Alternate interior, okay? Alternate interior angles are congruent, so the lines are parallel. Alternate exterior, okay? If you have alternate exterior angles and they are parallel, and they are congruent, then your lines are parallel. Same thing with same side interior, supplementary, same side exterior, supplementary, okay? So what's happening here is our lines are not going to be, they're not going to be shown as parallel. We are going to take these two different angle pairs and we're going to identify what kind of angles they are, and then verify that, hey, they're congruent or supplementary, and then so we're going to state the postulate or theorem that justifies our answer. Again, guys, this is just what angle pair do you have with these two angles, and just throw the word converse after it. I'm going to be completely honest with you, okay? So we're going to take a look at this first one, and we have angle 1 is congruent to angle 6. So if we look at angle 1 and angle 6, we're noticing we're not using line M. So we're going to notice that with your transversal, we're on alternate opposite sides, and we're exterior. Think about my pen as the car driving down the road. That's interior. We're exterior. So what we can state is that line L and line N those are going to be parallel by your alternate exterior angles converse. Okay, we're just saying what kind of angles converse after it. Next we have angles 2 and 3. So here's angle 2, here's angle 3. So now we are not using the line N. So we take a look at our transversal line P. Okay, 2 and 3 are on alternate sides, and now they are interior. So we have alternate interior angles. Therefore, since they are congruent, we can verify that line L and line M are parallel by your alternate interior angles converse. All right, so now we're going to solve. We're going to see here, we're going to find the measure of angle MRP. So right here, we're going to substitute in right here after we solve for X, okay, and we're going to identify what theorem we used. So the other angle they give us is over here, RPN. So we take a look here, we look at our transversal, and we're going to notice that we have alternate sides of the transversal, and we are interior. Well, it looks like a whale. I always draw the little car. If you've watched any of my videos or my class, that car is on the interior of the road. So we have alternate interior angles. So here, alternate interior angles converse. And we know that alternate interior angles are congruent. So we will set these equal to each other. So we have 5x plus 7 equals 7x minus 21. Okay, it's been a while since I've done a video walking through. I'm going to move my smaller variable first, but getting rid of it, subtracting. Bring down the 7. We have 7 x's. We took 5 away, so we only have 2 x's left. And then bring down 21. Since I moved the variable to the right, I need to move that constant, the minus 21, to the left. It is a minus 21 right now. I need to do the opposite and add 21 to both sides. 7 plus 21 is going to give me 28 equals, bring down your 2x, And then last but not least, divide by the number in front of x by that coefficient. X is going to give me 14. Remember that we do want to plug it in, okay? We want to find the measure of angle, here, the measure of angle MRQ was 5x plus 7. So I'm going to remove x, and whatever x was, I'm going to substitute that in, 14. And we do all the math, multiply 5 times 14, then add 7. The measure of angle MRQ is going to end up equaling 77 degrees. If we plug it into angle RPN over here, we should get 77 as well. All right, last one and last for the video. So we're going to find y so that we have parallel lines. And what's happening here is this is going to be a little bit different than a lot of things we've seen. Okay, we have parallel lines. And we're seeing here we have a perpendicular 90 degrees. Guys, if you have parallel lines and one angle is 90 degrees, they are all 90 degrees because you'd have, alternate interior. So this would be 90 degrees. These would be a linear pair, so that would make that 90 degrees. So let's go ahead and write this down. I'm going to write it down. Pause it right after this pops up so you can copy everything down. So pause, write this down. We've got a conditional statement here. If lines are parallel and a transversal is perpendicular, remember perpendicular is 90 degrees, then all the angles are 90 degrees. Go ahead and pause and write that down. So all it means here to solve for y, we just need to take 4y plus 10 and set it equal to 90 because that's how much the measurement is. So here we just got 2 real quick steps. We're going to subtract 10 from both sides. 4y is going to equal 80. And then we divide by 4. Y is going to equal 20. We didn't need to substitute back in because we already know it's 90. But plug it back in. See if you get 90. Like I said, very, very short lesson here. So remember that if we're asking you to prove that lines are parallel, just throw that converse onto the end of the name of the angles.